Okay, welcome to our first geometry online lesson of the year. This is Mark Dittmer. I'm a teacher at American Indian Public High School. And this lesson is basically reviewing some stuff we've already covered in Chapter 5 so that we can go on to cover some new stuff in Chapter 5. And so the stuff that this video is just going to cover this highlighted part of this objective here. And then next video we'll get into medians and altitudes, or we'll talk about those in class on Monday. And we're going to look mostly at this tab up here, which is so once you've got that objective copied down, and you can always, the nice thing about these videos is that you can always pause me, so I can't possibly go too fast. Just pause and replay me if you miss something. So after you've got this objective down, we're going to go over to this other tab which has some problems on it. And the first problem has to do with perpendicular bisectors. It says MN is the perpendicular bisector of TS. So MN is this line here. So the drawing, obviously not the greatest, but that's supposed to be point M right there, and that would be point N right there. And the line MN, so this should have arrows on it, is the perpendicular bisector of segment TS. Now I know it's segment TS because it ends, and that's supposed to be S right here, where these two, and that's T right here. And only a segment can have a perpendicular bisector, because only a segment can be cut exactly in half. So because it's cut directly in half, we know right off the bat the answer to this first question: what segments are equal? We can see it; it's labeled for us. Tn and Sn are equal. So for A, I would put Tn and Sn, and then but then I don't think that's the only two segments. So we got Tn and Sn. But also, since Mn is the perpendicular bisector of TS, that means every point on Mn is equally far from T and S. Every point on Mn. Well, so there's tons of segments that are equal, but only one other one that's labeled already, because we don't have labels for this point and this point. But we do have labels for this point, and that's on Mn. So Tm is congruent to Sm. So that's one thing, because we know about perpendicular bisectors. Every point on the perpendicular bisector is equidistant from the end points of the segment it bisects. Okay, then the second question is, why is Q on Mn? Why is Q on Mn? And to answer that, I'm going to look at the drawing a little more, and we're given something. So you can't have answered that yet, because you're given this. This is 12, TQ is 12, and SQ is 12. Now, what do we just learn over on this side of the drawing with the TM and SM? We knew those two were congruent because we said every point on the perpendicular bisector is equidistant from T and S. So kind of flipping that around the other way, we could say, well, every point that's equidistant from T and S must be on the perpendicular bisector, and that's true too. So the answer here is because it's equidistant. And sorry for the mess. Equidistant from T and S. T and S. All right, and so that's enough about perpendicular bisectors. All right, the next problem has to do with angle bisectors. Different. What are the angle bisectors? It says the angle bisectors meet. That's bisectors, not B. That's bisectors. Meet at point L. So that means ML, PL, and NL are the angle bisectors, right? I'm trying to erase that red mark I made. I don't want to confuse you. In any case, the question then is what segments are equal? Well, if you think all the angle bisectors that I just mentioned, ML, PL, and NL are equal, well, they don't look equal, do they? And that's not how it works. Those are angle bisectors. That means the angles that they bisect are equal, and that's what all these markings are supposed to show. Like the two, those have two lines here, and two lines here. This one has 3 lines here, 3 lines here, and 3 lines here. This one has 1 line here and 1 line here. That means they match each other. Those two angles are equal. But the angle bisectors are not equal to each other. However, where the angle bisectors meet, which is called the incenter, is equidistant from the sides. When you draw perpendiculars to the sides, those perpendiculars are equal, making this little circle, this circle that goes inside. So equal segments would be LQ, LR, and LS. Those are perpendiculars drawn to the sides from the incenter. And that's why it's a circle, right? It's 3 radiuses of the circle, so they're all congruent. Then the next question says, find LQ and LR. Well, luckily we know they're the same, right, as each other. So if we find one, we can find the other. Now, what's given to try to find this is that this segment here is 17. Then this segment here is 15, and this is a right angle. So if I redraw that on the next page, I would have 17 and 15 and a right angle, right? Do you see that? This is here, it's that triangle right there, and it's that triangle. Okay, so how are we going to find this? So you can always pause the video and come up with the answer during that pause. How are these things related? By the Pythagorean theorem. 15 squared plus that thing squared equals 17 squared. And you do the math, you get, that means x squared equals 17 squared, which is 289, minus 15 squared, which is 225. And what did I do there? I just subtracted the 15 squared from both sides, right? So, and that left x squared, that canceled on this side, and I just had x squared by itself, 17 squared minus 15 squared. And that equals 64. If x squared equals 64, then x must equal, drum roll, 8. So therefore, we know that LQ is 8, and so is LR, and so is LS. They're 8. They're all 8. All right, well, that's where I'm going to stop. If you need to see a better drawing of this video, and no doubt you do, the drawings, example 1, this one, was example 1 on page 265 of your geometry books, and example 2 was an example on page 274. And that's it.